My name is Luca Bergonzi. I'm the sales executive for Beta80, and I represent the EMEA market. Marcus will place a call, and we see how the call is treated.
Okay, I call you.
Okay. So now the call is online. If Marcus speaks closer to the phone, you can hear the loudspeaker and the phone call is in. I didn't touch anything on my screen because this is an automatic call distribution mechanism. However, the operator, when he has the phone on his headphones or loudspeaker, he will just create a new incident. And the new incident automatically connected with the Avaya backend imports automatically the phone number and does all the process behind it. For example, if there is a location-based mechanism, all the location data is automatically imported here. If this is for the e-call. Additional information. Here you see a number 2, which means that you potentially have 2 sources of additional information. These sources we are talking about are social media. So while we are talking, the system already scanned Twitter and Facebook for the elements which are being posted in real time close to the coordinates that we are talking to. The classical scenario would be you have a call because of an attack. You don't know it's a terrorist attack, you just hear somebody calling, I hear a huge noise, maybe an explosion or something like this. Okay, the next thing you do is to go on Twitter and look at the sequence of tweets who have been tweeted in the last period close to the location where you are. Okay, so this is 2 minutes ago in this location and so on. Similar to this, you go on the Facebook posts. We decided not to go just into every single Facebook post, but to dedicate our search on live streams. So now the streams, whatever are the, we now need to widen a little bit our search, but these are all the video streams in real time which are being detected close to our coordinates. Somebody in Cologne here is streaming, and we see in real time what this guy is streaming, because it's close to the coordinates we have been looking for. So now, once again, the terrorist attack case, imagine people going around with their phone, showing what's going on and so on. The police, for example, may see that in real time, considering all the data taken from the call. Then the other important thing is to qualify the emergency. So moving to another case, let's say we received a call for a fire case. So we say this is a fire case for a carbon monoxide kind of alarm. The system automatically looks, whenever you qualify it, for a proper procedure, if any, and it's shown here once it's found. So you know that for a carbon monoxide alarm, you have in your system a particular procedure to evaluate all the elements that are coming afterwards, what to do and what not to do for your staff on the field. And of course, you can insert plain text to add some notes and so on. This is all customizable elements. So for demo purposes, it's a very simple qualification. From now on, you are basically into the process of dispatching. So you're ready to go and dispatch. You may select that now fire brigades are the best to respond to such a case. You select in the list, now we have just one, but this is the list of potential fire brigades that should take care of the incident. And when you dispatch, you will see that a new, let's say, dispatch form appears here. So you can move and see your resources. What we present in the software is the, not selected, but the proposed resources to be dispatched. The resources who are already on scene in case the dispatch is already taking place. And you know that for example, this truck has these 3 people on board. It has a defibrillator and automatic, defibrillator device. And there is another one en route going to the same place. And then here you have the list of other potential resources who have not been selected automatically by the algorithm in the software. Having said that, this covers pretty much the process from the call taking and on. What is also important is to show, besides the call taking we've seen, the integration with other Avaya services. So we are now talking about Marcus call, which is still online. We integrated with the ILocate service. ILocate, as you know, allows an HTML5 based geolocation of the caller as well as multimedia share. So what we did was to get the primitive APIs of ILocate, put them into the software, and manage ILocate functionalities from here. So I will now send an SMS to Marcus. Did you receive it, Marcus, already?
Just a second.
Okay.
It's coming.
So through the SMS, I will send to Marcus an HTTPS link, which will be used to open a WebRTC session. The link Marcus is sending also sends us the location. So this is Marcus' location in a summary. And if I want, for example, to send Marcus a picture, which in this case is the Heimlich maneuver, if I'm not mistaken, Marcus, this goes to the phone from, let's say, the selection here in our CAD. Vice versa, I can ask Marcus to send back some pictures from his phone. Should I try? This is a history of some pictures we have seen. Now Marcus will take another picture from his phone with the upload button. Okay, so this is the last picture that Marcus was taking from his phone, and I got it directly into my screen. And we could go on with other functionalities. So the list of functionalities is all here. So video, images, and so on, and location are all connected directly into our software. Finally, we have seen the first screen. Let's say that normally the software runs on two screens, the second screen being dedicated to mapping systems. So whenever I am, let's say, far away from the location of my incident, let's say here, somewhere my map was centered here, through a single click of a button, I will move directly my map to the coordinates where the incident is taking place. You see here in this scenario number 17 incidents because we have been running over and over the same example. But we are actually just outside the PMR exhibition center. So the coordinates, considering we are in a closed environment and so on, are quite precise. On top of this, what we added, we've seen Facebook, we have seen Twitter. There is another social media we incorporated in the software, which is represented by this icon here. This is the Waze icon. So social media and driving directions at the same time. Waze is used by drivers to communicate the existence of car crash, traffic jams, and so on. What we have been doing was the let's say, integration with this data into the mapping system. I will now move to an incident which we created in Italy, because this is the typical example we have. Now, by moving to Milan, we also move our maps to Milan, and you will see some data here on the screen. This data is actually crowdsourced data, so it's in real time and it's made by citizens driving on the streets, reporting for traffic jams, reporting for slowdowns and other types of incidents. Let's concentrate on something which might be interesting for public safety answering point or in general contact centers. So these are the car crash or accidents, such as this one. This is in real time, so I'm just looking on the map on what's around. Somebody's telling me that here we have a car crash. With injured, without injured, I don't know right now, but imagine if I got a call from the same location, the call taker may be able to connect the two elements, one with the other, and say, okay, I know what's going on. Plus, this kind of interface or integration allows the contact center to do the other way around. Imagine, for example, here nothing happened yet, but I get a call of an incident. Me, as a call taker, while I'm working my own stuff regularly without no further interaction, I can send to Waze an incident information, and Waze will publish it for me. So, for example, in the text or in the additional data of the incident, I can say, this is 112 Milan. We detected an incident in your location. Please make sure to allow rescue teams to reach the place. So this is the first example of double-side interaction between social media and public safety answering points. There is nothing else like this.